Hi all. In last class, we have seen what is a page table, what is it used for, and all. Now we need to know how we can implement the page table. That is the hardware implementation of page table. First case is implementing the page table as a set of dedicated registers. That is, we will be taking some registers and they will be dedicated just for page table. But the problem here is this can be used only when page table is reasonably small. Next case is keep the page table in main memory and page table base register, that is PTB, points to the page table. Here, instead of using dedicated register, keep the page table in main memory and a register called page table base register, which points to the page table. But here the disadvantage is we are increasing the time used for accessing a user memory location. Why? We are making two memory access here, one for page table entry, another for the byte itself. The solution is we will be making use of translation look aside buffer, that is TLB, in order to do the hardware implementation of page table. TLB is an associative high speed memory which consists of two parts. One part is key and the other is a value. When the associative memory is present with an item, the item is compared with all keys simultaneously. If the item is found, the corresponding value field is returned. The search is fast. But the TLB contains only a few of the page table entries. When the CPU will be generating a logical address, that page number is presented to the TLB. So, we are expecting that it may be present in the TLB. If the page number is found, its frame number immediately available and is used to access memory. That is TLB hit. If the page number is not in the TLB, a memory reference to the page table must be made. That is TLB miss. This is the basic functioning of TLB. So let us take a diagram and discuss quickly what we discussed. So in this diagram we can see TLB here, page table here, and main memory. We know CPU will generate a logical address. We need to translate this logical address to physical address. In order to do that, we are going to make use of TLB now. So, this is the hardware implementation. CPU is generating logical address. We know that logical address consists of page number, which is P, and page offset, which is denoted by D. First of all, what we will do is we will check whether the page number is present in the TLB. TLB consists of key, value, pair. Key is the page number and value is the frame number. We are looking page number. If it is present in TLB, then we will be directly get the frame number. That is TLB hit. That means we found it and corresponding frame number returned. Let's say F is the frame number and D is the offset. The same offset passed over here. If we combine the frame number with the page offset, we will be able to arrive at physical address. This is the case of TLB hit. The next case is TLB miss. If we looked up the particular logical address generated by the CPU and we did not find it in the TLB, so this is the TLB miss. In that time, we have to make a reference in the page table itself. From the page table, we will be able to find frame number. Then we will be able to arrive at the physical memory. Whenever we get a TLB miss and we find the corresponding frame from the page table, then that entry will be stored in the TLB now. Hence, the next time we are trying to get the corresponding page number, we'll get it from TLB itself. So, TLB is fast and best hardware implementation of page table.